Welcome to the New Calculus channel. My name is John Gabriel. In this video today, I will be discussing the big deception. The big deception is really something that happened in the last century, or really towards the end of the 19th century, in an attempt by fraudulent academics to state that the calculus was made rigorous. You had books published by that idiot Judith Grabiner. I think it was called Who Gave You the Epsilon and Delta, and several others which covered the topic of limits and how they supposedly rigorized calculus. Well, I'm going to show you in this video how all that came to be and why it was a deception, and that there wasn't any rigorous calculus before the new calculus. So let's begin with Weierstrass's original definition, and you're looking at it right now in front of you. Well, if we read it, it says the difference f x plus h minus f of x is called the change that the function undergoes. That's absolute rubbish. The function doesn't undergo any change, and it's already called a difference. So why call it the change that the function undergoes? You see that right over here where I'm pointing to with my little pen. That's just nonsense. No change is happening to the function. And then it says while x is changed into x plus h. Well, x cannot be changed into x plus h. So he says, now if it is possible to determine a limit delta such that for all values of h with absolute value smaller than delta, then the difference will become smaller than any arbitrarily small quantity. Then one says that infinitely small changes of the argument correspond to infinitely small changes of the function. But immediately one asks oneself, what on earth does arbitrary small quantity mean? Well, you'd have to read a little further to see how Weierstrass defined that. He says, indeed, if the absolute value of a quantity can become smaller than an arbitrary small quantity, then one says that it can become infinitely small. So really, if q is a quantity, what Weierstrass is telling you, look up here, is telling you the absolute value of q, right, can become smaller than any arbitrary quantity. So if it can become smaller than any other arbitrary, so we'll say arbitrary quantity, like that, then that implies that this q here, or this quantity, that q, becomes infinitely small. Can you believe that? That's absolutely outrageous nonsense. I doubt anyone in their right mind would believe that that is a valid definition of anything. Weierstrass is saying, this is how he's defining an arbitrary small quantity. He's saying it's that quantity which can become smaller than any other arbitrarily small quantity, and that implies that the quantity itself becomes infinitely small. So infinitely small is this process here, where if q is less than any arbitrary quantity, then it's infinitely small. I don't honestly understand how any academic can accept that as a valid definition. Okay, so that in itself is just such rot that it amazes me anyone could really have written anything like that. But anyhow, if we translate what Weierstrass did here in this original definition, it boils down to this. The distance between x and c is less than delta implies that the distance between f of x and L is less than epsilon. and L is equal to f of c. This here is actually the definition of continuity according to Weierstrass. Okay? And of course in this case here you can have that equal to 0. In the limit definition it has to be greater than 0, because why do you think that in the limit definition this value here cannot be 0, but it has to be greater than 0? Why do you think that? Well, if it is equal to 0, then the finite difference is undefined. Then this rot by Newton, this rot becomes undefined. And that is the reason we need this condition in here. So what modern academic morons did is they took this definition here and they added this inequality, in fact that this distance must be greater than 0, because if it's not greater than 0, then obviously this finite difference is meaningless, because it assumes the form 0 over 0. Now, the modern definition is really a definition that doesn't even allow this. Okay, so in other words, the limit is not even defined at the point of continuity, but in actual fact you cannot show me a single function where the limit is not equal to f of c. I challenge you to show me such a function. There is none. Okay, because if there is continuity at that point, then the limit is defined. But the dishonest, the creepy, the insecure modern academics will try to sell you and brainwash you with this rubbish. Now, let's look at this very carefully. Let's see what the creeps did throughout the decades. So they developed techniques to brainwash you, and here are some of these techniques. They will, for example, draw a graph. Let's say f of x is equal to, let's say, 3, yes? And then they'll put a hole somewhere along this graph. Let's say I want to put a hole at x equals 1. Then what they'll do is they'll multiply this function here by x minus 1 over x minus 1 to get 3x minus 3 over x minus 1. And now, what have they actually done here? In this particular case here, they've just multiplied by 1. Yes? But when they give you this particular function without you having seen this before, the idiots will tell you that this is not defined at 1. Well, of course it is defined at 1, because if you're allowed to multiply by 1, you're also allowed to divide by 1 to get back to what you had, which is y is equal to 3. So the unbelievable morons will put a hole there by multiplying it by 1. There is no hole there, but that's what they'll tell you. And the same thing happens with this infamous limit, where you have the limit as x approaches 0 is equal to 1. This here is a well-defined function. It's just not in its irreducible form. Okay, so this function here is defined at 0, contrary to what most academic morons will tell you. And there is nothing special about this particular limit, but they will place unnecessary constraints on you and heavy burdens, with you having to learn a lot of theory that doesn't even matter in the first place. But they will do that in any event, okay? Just so that they can have job security and that they can look intelligent, but they're actually so stupid that their stupidity cannot be measured. Right, so now this here is really the big deception. The fact of the matter is that you cannot have a rigorous calculus unless this here is greater than 0. It has to be greater than 0. But originally, Weierstrass didn't even define it that way, and he wasn't even talking about a limit. He was talking about continuity. And in Weierstrass's definition, L is equal to f of c. But of course, modern academic morons couldn't have that, because if that were the case, then this finite difference here would equal to 0 over 0, and that, of course, is not acceptable. So this is part of the rot that you have to learn, and you can find out more in my debate with Mark Andres, actually Andres Kessorg from MIT, how he tries all sorts of hand-waving arguments to get around the fact that Cauchy's derivative definition, this here, is actually a kludge, and it's not rigorous at all, it's not well defined, and it's not rigorous. But this is what you have to learn. And this is the kind of nonsense that you're burdened with in mainstream calculus. In the new calculus, there are no limits, there are no infinitesimals, and there is no such thing as infinity, because infinity is a junk concept. Well, I hope you have enjoyed this presentation, and if you have any questions, please feel free to go to my New Calculus Google site and post a question there. You have to join the group first. If you do that, I'll be able to answer your questions about the new calculus, or any other questions you may have about this particular video. So that's pretty much it for this video today, and I hope you've enjoyed it and will join me again in the near future for another video. My name is John Gabriel, and this is the New Calculus channel. Till next time, goodbye.